Hey guys, Mr. Bowman here. I've got two questions in blue, but today we're looking at how we can use trigonometry and Pythagoras' theory to solve problems from context. So context, just a reminder, they are scenarios where you're not really given the triangle, rather you're given a whole bunch of words. So when you're doing these questions, just a reminder, the first step you need to do is you need to draw your triangle. And you need to put all the information you know. And once you've done that, you can then follow all the steps for either trigonometry or Pythagoras' theory, whichever one you're using, to then calculate the missing side or whatever you're trying to find out. Just a reminder, when you're dealing with trigonometry, you should have two sides and one angle. And don't forget Pythagoras' theory. You should have three sides and no angles. So sometimes it is difficult to tell between, well, when am I using trigonometry, when am I using Pythagoras' theory? But hopefully that gives you a bit of guidance as to what to do and when. So let's get into our questions. So a boat is 200 meters from a cliff. So let's draw that. So kind of here's my cliff. Cliffs are normally straight up and down. And then maybe I'm going to draw my boat here. Forgive the poor drawing, but I'm going to give it my best go. Maybe there's the rudder and there's the boatie. And kind of the water is a bit squiggly as well. So this bottom dimension here, that there is 200 meters because he's 200 meters away from that cliff. Okay, so we've done that first. Cliff, and then we've been told which is 275 meters tall. So we'll write 275 meters here. So our diagram's not to scale, but there you go, 275. Calculate the angle of elevation from the boat to the top of the cliff. So we're from the boat going to the cliff, and we're trying to find out the angle of elevation, which is the angle going upwards. So as we're trying to calculate that can be our unknown x. And we've got, hopefully you can see that there should be our right angle, and you can see a triangle coming up from our diagram. Once we've got our triangle drawn, we now need to figure out, well, am I going to be using trigonometry, or am I going to be using Pythagoras' theory? And I can see I've got two sides with one angle, so that's an indicator that I'm going to be using trigonometry. So let's get into that. Trigonometry, first step you got to do is you got to label your sides. So we've got the hypotenuse, which is opposite the right angle, opposite, which is opposite the given angle, and the adjacent. We don't care about the hypotenuse, but we do care about the O and the A, which means we're going to be dealing with tan. So let's get that in. Tan angle is equal to O divided by A. Let's substitute the angle, which is this theta. That's x because we don't know what it is. Tan x is going to be equal to O, which is 275, divided by A, which is 200. X is going to be equal to tan negative 1. 275 divided by 200. This is when we're going to grab out our calculators to calculate what x is. So I'm going shift tan to get us tan negative 1. 275 divided by 200, close bracket, that is 54 degrees. And that there had a rounding of 0 decimal points, so rounded to the whole number there. So that there would be our angle of elevation. So in this type of question, it's probably customary to write a sentence, just to wrap up my answer. So the angle of elevation from the boat to the cliff, cliff is 54 degrees. There we go, question 1 done. Question number 2, the apprentice has constructed a wall which is meant to be 2 by 5 meters. The wall should be a perfect rectangle, okay? So it's a bit weird, we're meant to be dealing with triangles, but we've got a rectangle. So let's say this side here can be the 2 meter side, and this side here down the bottom can be the 5 meter side. And there should be 4 right angles. Okay, there we go, 4 right angles. If the boss wants to check his work, what should the diagonal measure? The diagonal refers to the top corner to the bottom corner. You could have gone the other way, but we'll leave that there. And you can see once we've drawn that diagonal, you can see that right angle appear because we've got our right angle down the bottom. And we're trying to find the diagonal length, so that there would be our x value. Maybe we change that to y because we used x in the previous question. There's our y. So we've got our right angle triangle. Okay. We now got to figure out, what am I using, Pythagoras theory or trigonometry? And you can see I've got 3 sides, nothing to do with the angles. That tells me I'm going to be using Pythagoras theory to answer this question. So let's write down Pythagoras theory. A squared plus b squared is equal to c squared. Now I've got to figure out, well, how does this relate to my triangle? I'm going to label my sides, just like I did, but this time around A, B, C. So A and B, they always join to make the right angle here. And opposite to the right angle is C. I'm now going to substitute. So we know that A is 2 and B is 5. So 2 squared plus 5 squared is going to be equal to, our C is going to be y squared. That becomes 4 plus 25 is equal to y squared. Y squared is going to be equal to 29. I'm now going to do the opposite of a square root, to get rid of that. So y is going to be equal to the square root of 29. And y is equal to, going to grab out my calculator for this final step, square root 29, that is equal to 5.4 meters, and that they had a 1 dp rounding. So that means if the apprentice constructed the wall correctly, he's got all the right angles sorted, this measurement going across in the diagonal should be about 5.4 meters. So let's put that in a sentence. The diagonal measurement of the wall should be about, and the reason I'm saying about is because I did end up rounding it, so it's not quite correct, but it should be about 5.4 meters if the apprentice constructed it correctly. There we go. So thanks so much for watching, guys. Hopefully this gives you a bit of a process or a bit of a guidance as to how to answer questions, just the wordy, annoying ones. Now let's get into heaps of practice.